Alright guys, we're starting chapter 2, which is the cool unit because we get to learn about derivatives, and derivatives are cool. Except for the definition. The definition of a derivative is not cool, but the derivative shortcuts are cool. But before we use derivative shortcuts, we gotta learn the actual definition. So that's what 2.1 is gonna go through. 2.1 and 2.2. I don't know why I didn't write 2.2, but whatever. So, the definition of a derivative is given right here, and it looks really whack, but it basically just means, this just means the slope of a secant line between 2 points, and the 2 points are x plus h, and, whoops, I got that backwards. The 2 points are x and x plus h. And so we have a curve. We're trying to find the slope between those two lines, but then we take the distance between these two. The distance, the horizontal distance, is going to be h. The distance between x and x plus h is just whatever the value of h is. You take x and you add a distance of h, okay? So if we let this value right here go to 0, then that means that these 2 points get closer together, and that's how we create a slope of the tangent line, or we find the slope of the tangent line. And so that's what we do here, and it's actually really cool that we can find the slope at a point. So for question 1, we're trying to find the derivative at x equals 2 for the function of 1 over x. And since you're watching this video, you have to listen to my very long explanation, and you guys are probably thinking, I don't want to listen to your explanation, I want to just know what the answer is going to be. Well, too bad, joke's on you guys. So here's 1 over x. We're trying to find the slope at this point, the exact slope at x equals 2. So that's what we're looking for. Can we find the slope? Good thing we have calculus so that we can. So we're just going to follow this definition. We're first going to find what the derivative is. The derivative just means the slope, and the derivative is going to be, so we're going to say f prime of x is going to be equal to f of x plus h. And so we're going to take 1 over x, and we're going to plug in x plus h. So it's going to be 1 over x plus h. Okay, so this right here is f of x plus h, that's what f of x plus h is, minus f of x, and that is f of x. So minus 1 over x over h, and I'm such a noob. My goodness, I didn't write the limit. What's a derivative without a limit, am I right? So there we go. Okay, so the limit as h approaches 0 of this expression right here will give me the derivative. But we do need to simplify this because, again, we have the limit as h approaches 0, which we know we can't plug in 0 right here. So we have to manipulate this in order to evaluate this limit. To find the value of this limit, this needs to be manipulated to the point where I can plug in 0 for h and not get 0 in the denominator. So let's manipulate. Well, how else am I going to manipulate than by combining these two terms, and I need to get a common denominator in order to subtract them. So to get a common denominator, I'm going to multiply top and bottom of this expression by x plus h. So times by x plus h times by x plus h, but I also need to multiply this side by x. Okay? So then I get f prime of x is equal to the limit as h approaches 0 of x. I'm not going to write the denominator just yet. I'm going to do x minus, because now that I get a common denominator here, this becomes x, and then I can subtract the numerator, so x minus, and then this is going to become x plus h, but the negative also has to distribute. So this becomes negative 1, and then it becomes negative x minus h. Okay, all over my common denominator of x times by x plus h. I'm not really going to bother foiling out the denominator, okay? And then this is all being divided by h, and I'm going to call this h over 1, because then I can think about it as a keep, change, flip. And so whenever I do that, this is going to be multiplied by 1 over h. So I did the keep this part right here. I changed this part to multiplication, and I changed this to be 1 over h. Now, if I simplify the numerator right here, I get x minus x, which cancels. So I should just be left with, so I get f prime of x is equal to the limit as h approaches 0 of negative h over x times by x plus h times by 1 over h. But then you can also see that those are going to cancel. The h will cancel. So then I get the limit as h approaches 0 of negative 1 over, now I'm going to distribute, I guess I can, doesn't really matter, x squared plus xh. Okay, so this was the whole problem from the beginning. This h right here, I couldn't plug in 0 because it gave me 0 in the denominator. But I got rid of it right here whenever I canceled those out. So now it's not a problem. I can plug in 0 and I can evaluate the limit. So this will be equal to negative 1 over x squared. Because if I plug in 0 right here, that goes away. So negative 1 over x squared. This right here is the derivative. Okay, and then I want to find the derivative at 2. So f prime of 2 will be equal to negative 1 over 2 squared, which is going to be negative 1 over 4. So the slope of the line at x equals 2 here is negative 1/4, which is pretty cool. Pretty cool that you can find the slope at a given point. All right, let's try 2. So for 2, we have our function f of x. We're trying to find the derivative at negative 1. So let's just first find the derivative, f prime of x. F prime of x is going to be equal to, don't forget the limit this time, the limit as h approaches 0. And we're going to plug in x plus h into the function. So 3 minus x plus h squared minus, so we got the minus part right here, minus f of x, which is the function. Make sure to put this in parentheses because either put it in parentheses right now or you need to distribute because multiple terms right here. In fact, okay, no, I won't, I'll wait. And then all divided by h. So again, we have f of x plus h, we have f of x, and we have h right here. H is in the denominator, that's the problem. So we have to expand this, we got to simplify, somehow get rid of that h right there. So f prime of x is going to be equal to limit as h approaches 0 of 3 minus, I'm going to do some scribbles over here, x plus h squared is x plus h times by x plus h, which is x squared plus 2xh, because this becomes xh and this becomes xh, so you get 2 of them, and then plus h squared. And then, so this is going to take the place of x plus h squared right here. Don't forget that it's a negative here, so that's going to distribute to all 3 terms. So I'm just going to think about this right here. So negative x squared, negative x squared, and then minus 2xh minus h squared. Okay, so that's that part foiled out, and then I have minus 3 plus x squared all over h. Okay, all right, and now on the numerator, I have a positive 3, I have a negative 3, I have a negative x squared, I have a positive x squared. So then I have the limit as h approaches 0 of negative 2xh minus h squared over h. And because both terms have an h, this has an h, this has an h squared, that can cancel with one of those factors. So then this will be equal to the limit as h approaches 0 of negative 2x negative 2x minus h. Okay, so again, we got rid of this h because it canceled out, but I can't just cancel out from one of them. It's as if I'm factoring out an h and then canceling that out. But because they both have a factor of h, it can cancel out with that. And now we can evaluate our limit. The limit as h approaches 0 is going to be equal to negative 2x. So this is our derivative. And so f prime of negative 1 is going to be negative 2 times by negative 1, which is going to be equal to 2. So the derivative of this function at x equals negative 1 is 2. Or in other words, the slope of this function at x equals negative 1 is 2. All right, for 3. Going again, we're going to have the limit as h approaches 0. We're going to have to use x plus h for x for the first part. So x plus h, plugging that in. So that'd be the square root of x plus h minus f of x, which is square root of x, over h. So this will be f prime of x. Okay, that's going to be equal to the limit as h approaches 0. And then, well, hold up before I go any further. We've seen expressions like this before, where we have radicals. And when there are radicals, we have to use conjugates. So the conjugate here would be we have to multiply this by the square root of x plus h plus the square root of x. And then we have to multiply the denominator by the same thing, x plus h plus the square root of x. So this will be equal to the limit as h approaches 0. When I FOIL the numerator out, so x, the square root of x plus h times the square root of x plus h is going to be x plus h. I don't care about the middle terms or the inner and the outer terms because they will cancel out. And then negative square root of x times positive square root of x will turn out to be minus x. All over, excuse me, we have h times by the square root of x plus h plus the square root of x. And you can kind of see this unraveling here. Those are going to cancel, which means I'll be left with h on the numerator, which can cancel with that factor. So ultimately, we'll just have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Now we can plug 0 in for h because that h isn't there anymore. And that's going to be equal to the limit as h approaches 0 of 1 over the square root of x plus the square root of x. I don't need the limit anymore because I just substituted my value. So it's going to be equal to that, which is then going to be equal to 1 over 2 square root of x. And there's my derivative, which means that f prime of 2 is going to be equal to 1 over 2 root 2. I'm pretty sure I meant to type in 4 because if it was 4, then this would be square root of 4, which would be 2, and that would be 2 times 2. So then it would be 4. I think I wanted it to be 1/4, but it don't matter. Anyways, we found the derivative at, you can leave your answer like that, that's fine. Alright, there's the first part. I'll finish this, the rest of this in another video.